So yesterday's lesson, or Friday's lesson, we saw long division. Today we're going to learn a shortcut method called synthetic division. It doesn't work with every single type of dividing polynomials. It only works when your polynomial is in the form where your variable is by itself. It has to have a coefficient of 1 and an exponent of 1, and then plus or minus some constant. So what we do is, first of all, we need the polynomial we're dividing into to be in standard form. So we have to rearrange this one. And then what we do is we drop all of the variables and we just use the coefficients to divide. So we put the coefficients kind of inside a box. So our first coefficient is 2. Our second coefficient is -1. We're missing the y term, so that coefficient is 0, and then our constant is 25. The polynomial or the binomial that we're dividing by, just the constant goes on the outside. And remember, this is in the asylum. So when we're dividing, when we're doing synthetic division, it's not -3, it's +3. First thing we do is drop down our first number, which is 2. And then we multiply. 3 times 2 is 6. We add this time, whereas long division you subtract, this time we add. 6 plus -1 is 5. 5 times 3 is 15. Plus 0 is 15. Times 3 is 45. Plus 25 is 70. So here's how we get our answer, because our answer should have some variables in it. These are now the coefficients for our answer. We started with our polynomial to have a power of 3. So our answer will start by having a power 1 less than that, or 2. So this 2 is the coefficient of my first term, 2y squared plus 5y plus 15. Well, that's already my constant, and I still have this 70 that I haven't done anything with. That's my remainder. So plus 70 over what I originally was dividing by, y minus 3. So that's our final answer. Let's take a look at a couple more. This one, again, is not in standard form, so I'm going to rearrange it. 9x squared plus 3x minus 2. Again, what I'm dividing by has the x term, or the variable, all by itself. Coefficient of 1, power of 1. And it's a binomial. I'm just adding or subtracting a constant. So I put my coefficients inside the box. This time I'm not missing any variables, so I don't need any zeros. Outside the box is the opposite of -1/3, which is +1/3. Drop down your first number, 9, times 1/3 is 3. 3 plus 3 is 6, times 1/3 is 2, plus -2 is 0. My original polynomial that I started dividing into had a power of 2, so my 9 right here will be a 9x, because we're going to have 1 degree lower than what I started with, plus 6, and this time there was no remainder. So x minus 1/3 goes into 9x squared plus 3x minus 2 evenly. One more example, and then we're going to see synthetic substitution. This one, our polynomial, is in standard form, so I'm just going to start by setting up the coefficients. 3x to the 4th, -1x cubed. We're missing the x squared term, so that coefficient is 0, plus 5x minus 1. The opposite of 2 is -2. Bring down the 3, times -2 is -6. Plus -1 is -7, times -2 is 14, plus 0. 14 times -2 is -28, minus 5 is -23, times -2 is +46, plus -1 is 45. Alright, so then to get our answer, again, we're going to drop 1 power, 1 degree from what we started with. So this will be 3x cubed minus 7x squared plus 14x minus 23. And we have another remainder, so plus 45 over x plus 2. All right, synthetic substitution is a way to evaluate a polynomial using a very similar method to the synthetic division. So again, I'm going to start by setting up my coefficients inside the box, 1x squared minus 1x minus 30. It's got to be in standard form again. This time, because we're actually evaluating x equals negative 8, we use the negative 8. We don't make it opposite with the synthetic substitution. And then the process is the same. Bring down the 1 times negative 8 plus negative 1 times negative 8 minus 30 is 42, and this right here is the answer. So that's the same thing as if I substituted negative 8 into my p of x function. So we'll evaluate it the long way to show that they're equal. Negative 8 squared is 64. The opposite of negative 8 is positive 8 minus 30. 64 plus 8 is 72 minus 30 equals 42. So the synthetic substitution with a polynomial like this wasn't a whole lot easier, but when we look at example B, it will be quite a bit easier because there's a lot more going on and we've got a lot higher powers. So we'll look at one last example. Again, setting up our coefficients, 3x to the 5th. We're missing an x to the 4th and an x cubed, so we need 2 zeros. 4x squared plus 1x plus 6. Again, with the synthetic substitution, we use the value we're given, x equals 1. Bring down the 3 times 1 plus 0 times 1 plus 0 times 1 plus 4 times 1 plus 1 times 1 plus 6 gives me a result of 14. Hope you're having a great weekend. I'll see you on Monday.